All right, so the second type of polynomial division that we can do is something called synthetic division. So because polynomial long division can be very tedious and it's just kind of a long process, they've developed a shortcut method. So when we think about division, we're really just doing an algorithm. We decided what goes in, what we're dividing by, what we're multiplying by, what we're subtracting by, bring down the next number. How many times does it go in, multiply, subtract, record the number, and it's very repetitive. So because we can do that, we thought, well, why not use another more algorithmic method to solve these? And it works if you do it another way. So the way that synthetic division is going to work here, if we're going to do this first example, is you always take what x here is equal to. So if I had x minus 5, x is going to equal positive 5, like as if we were solving that for 0. Then we put positive 5 in this little box in the corner. So we're putting 5 in a box. You're then going to take all of your coefficients. So in this case, it would be 1, negative 2, and negative 15, each of our coefficients across the top. You're going to leave some space, and you're going to draw a line. So this is your setup. Okay? From there, you always drop down the first number exactly as is. Notice we don't have any x's or y's or anything here. We're just dealing with the numbers and the coefficients, and we'll put the variables back in. So you bring down the first number. Then the rule is that we multiply, and that goes underneath the next spot. So 5 times 1 is 5. And then we're going to add down our columns, which gives me 3. Again, we multiply the 5 by the 3, and that goes in the next column, which is a 15. And then we add down our columns, which is a 0. And I'll kind of show you that to you. We have this is your factor, goes in the box. And then you have your coefficients. I'll just do COE. You know what, maybe we'll even do an F column. The first one gets dropped. And then it is multiply. So this would be CF for your coefficient times your factor. And then you add down the column, which in this case would be CF. And then you repeat. So then this gets multiplied, which would be CFF and CFF plus E in a way, if you can kind of see what I'm doing here. And then you're going to continue on. And the number that goes here is always your remainder. So in the case of our original problem, I always put a box around this number. That's going to remind me that that's my R. And then you work backwards. Coefficient, x, x squared, x cubed, and so forth. So this whole problem, x squared minus 2x minus 15, is just x, 1x, plus 3. With no remainder. And if we wanted to check that, we could do x plus 3 times x minus 5, and it FOILs out x squared plus 3x minus 5x minus 15. Combine like terms, and we get what we started with. So I know that was a lot, so I'm going to just show you that algorithm again in the next problem. Okay. So the way we set our problem up is we get a box. Inside that box, if you were to solve for x, x would be equal to negative 1. Then we peel off all of our coefficients. So that's 1, negative 9, and negative 10. We always start by dropping the first number. Then we multiply. We're going to do negative 1 times 1. And we get negative 1. And then we are going to add down this row here, which is going to give us negative 10. And then again, we multiply negative 1 times negative 10, which is going to give me positive 10. And we're going to add down that row again, which is going to give me 0. I always put a box around this last number. That is always your remainder. Then you work backwards. You have your constant your x, and if we had more, we'd go x squared, x cubed, x to the fourth. So this just comes out to x minus 10. So nice and easy. But it's just a new algorithm to get used to, so it's really whichever one you're more comfortable with in the end. Let's take a look at number 9. The setup here is a little different, so if you want to rewrite that like this, you may find it helpful. So what's going to go in our box is a -7. Again, you would set this equal to 0 and solve for x. So -7 goes in our box. I'm taking my coefficients, 1, 9, and 14. Always drop the first number. Multiply, then add, then multiply, then add. X plus 2 is our answer, no remainder. So it's kind of the opposite of what we do in division. Division, we divide, and then we multiply, and then we subtract. Here, we are just multiply, add, multiply, add, multiply, add. Of course, they're not always going to come out perfectly, so let's check in on number 10 here, one that's going to give us a remainder. So what's going to go in the box is a +1. If x minus 1 equals 0, then x equals 1. My coefficients are 1, 5, and 6. I'm going to bring down my first number, which is a 1. 1 times 1 is 1. Add gives me 6. 6 times 1 is 6. Add gives me 12. So now 12 is my remainder. So this is my constant term. This is my x term. So just like for regular division, you're going to write it out as x plus 6 plus 12 over, and we were dividing by x minus 1. And that part should look a little familiar to you from our long division day. All right, what about a little bit of a longer one? Ooh. Let's do one that's more than just a trinomial. And let's also look at a small issue we have here. So this one is 3x plus 6, which is not in the form of x plus 6. So we do want to solve. So I'm going to do 3x plus 6 equals 0. 3x equals -6. I'm going to divide by 3, and I get x equals -2. But I want to come back, and we'll come back to this idea that we divided by 3. We'll come back to that in a little bit. But let's do our synthetic division. So I'm using -2 here. -2 goes in my box. Pulling off my coefficients are 3, -5, 10, and -3. Make sure to show subtraction as in addition of a negative. I start with 3. 3 times -2. 3 times -2 is -6. Add down my row, I get -11 times -2 is +22, which gives me +32 when I add, and -64 when I multiply, which is a -67 when I add. So your remainder remains your remainder, but 3, -11, and 32 are not actually our answer. Remember when we divided by 3 up here? Well, we want to make sure that everything was divided by 3. So I'm going to divide each of these by 3 for my answer. Now, let's be smart about this. This is our remainder. This is our constant, this is our x, and this is our x squared. So when we write our finished product, we're going to have x squared, 3 over 3 is 1, minus 11/3 x plus 32/3 minus 67 over 3x plus 6. So this last term is still -67. It's not in thirds because you're writing it. Dividing by that third is still in here. So it will end up being divided by 3 because of this 3x. But these all also need to be divided by 3. For this reason, I tend to do long division when I do problems like this, just because the chance for error is a little higher when we add in that little step. So generally when I see a problem that has a coefficient for what I'm dividing by, I revert to long division where we don't have any of those funky rules. And then I use synthetic when it is given to us in a divided by like x minus 1 or x minus 6 or something like that. But it absolutely does work for either or. The last thing that I wanted to mention that I don't have an example here for you, let me just make sure that I don't have an example here for you, is if you were to divide, let's say, 3x to the fourth plus 2x squared minus x by x plus 2, that you need to make sure we have all of our placeholders. So here I need a placeholder, and here I would need a placeholder. To set this problem up, I would have -2 in a box, and then I would have a 3, a 0x cubed, so a 0, a 2, a -1, and then this is a plus c, which would be 0, and another 0. And I just want to make sure that you would know that just like in long division, that those placeholders exist. So again, this is a slightly different algorithm, which includes multiplication and addition, and what makes it look so much more simplified is the fact that we peel off all of our variables and add them back in the end, like we did right here in number 11. And I think that people just find this easier to look at and a little bit more organized, and they tend to not be as lengthy because some of our long division problems became very long. These are always going to stay neatly in 3 rows. So I would like you to practice with this maneuver. For the assessment on this, I would definitely want you to be able to do both synthetic and long, and then we're also going to do factoring. And then after this point, after you're tested and you know how to do all 3, then your preference gets to kick in and you'll have a little bit more choice throughout the rest of the school year.